Well guys, I'll try to demonstrate question number 5 on the problems that are on Schoology on my iPad here. And I'm sure that you remember that in a single slit diffraction we have a large bright central maximum with a minimum on each side. And so here is our minimum on each side, and there's the center of our central maximum. So to solve this problem, what we have to do is find the distance from the center of the bright maximum out to the first minimum. And then, of course, once we've done that, we've got half of it solved, and we have to multiply it by 2 to get the full width. This area here we will call y, the distance from the center to the first minimum. So I suggest that you start by drawing yourself a diagram. Here's the gap, and here is the center line going out to the center of our bright maximum, and here is the angle theta from the first minimum. And so we'll notice that this angle theta is very small. So if theta is very small, we immediately remember that sine theta is approximately equal in this sort of situation to tan theta. Writing on an iPad's never that easy. Therefore, what we end up with is that y divided by L is approximately equal to lambda over d, or in the case of a single slit we might call that dA. So what we need to know now is what's our data. So reading off the question, lambda equals 700 nanometers, and that's 7 by 10 to the minus 7 meters. Then, of course, D, or A, I'm going to call it D, equals 0.0002 meters. And our length was 6 meters. So, we'll apply that to our formula. Y over 6 is approximately equal to 7 by 10 to the minus 7 divided by our gap. So that means, therefore, that y is going to be approximately equal to, when we multiply it out, 3.5 by 10 to the minus 3 multiplied by 6. So there's our 6 over here. And that equals 2.1 by 10 to the minus 2 meters, which of course is 2.1 centimeters. Now that's only given us the distance from the center to one side. So to get the other side, we'll multiply that by 2 for two sides, and so our answer is going to be 4.2 by 10 to the minus 2 meters, or 4.2 centimeters to two significant figures. And that's the solution.